It's official. Oxygen has been directly detected on Venus's Dayside atmosphere. It's official. Astronomers peering at the atmosphere of Venus directly detected clear signs of atomic oxygen in daylight hanging about above the planet's toxic clouds. Atomic oxygen is known to exist in the planet's atmosphere according to theoretical models and has even been directly detected on Venus's night side. But the day side detection means we have new insight into the dynamics of the Venusian atmosphere and the circulation patterns therein, says a team led by physicist Heinz Wilhelm Hubers of the German Aerospace Center DLR. Venus is a world that scientists are itching to study in greater detail. It's similar to Earth in many ways, but utterly, hellishly different in others. Its mass and composition are like Earth's, but where Earth is lush, verdant, wet, and crawling with life, Venus is a death pit. It's cloaked with thick, choking clouds mostly composed of carbon dioxide, creating a greenhouse environment that leads to average surface temperatures around 464 degrees Celsius. That's 867 degrees Fahrenheit. Those clouds drop acid rain on Venus, and the entire atmosphere rotates around the planet at a tremendous rate. Winds far below Venus's clouds tops can scream along around 700 kilometers, that's more than 400 miles an hour. On Earth, the highest wind speed ever recorded was hurricane gust of 407 kilometers, that's 253 miles an hour. We don't know how Venus and Earth ended up so very different from one another, but studying our neighbor could help us figure it out. Was Venus once on the same path as Earth and took a wrong turn somewhere, or was it the evil twin from the start? Understanding the atmosphere of Venus could help us understand the differences between it and Earth, and one of the ways to do that is by following the oxygen. Atomic oxygen is not like the oxygen that you breathe. The latter is molecular oxygen, or O2, consisting of two oxygen atoms bound together. Atomic oxygen consists of single lone oxygen atoms, and it does not tend to last very long because it's highly reactive and easily bonds to other atoms. Here on Earth, it's abundant in high altitudes, where it's created by photodissociation of molecular oxygen. Basically, solar photons break apart the atmospheric O2. A similar process is thought to take place on Venus. Venus's atmosphere is predominantly carbon dioxide. When light from the sun hits the CO2, photodissociation spills the molecules into atomic oxygen and carbon monoxide. The carbon monoxide is also subject to photodissociation. And when these atoms travel around to Venus's night side, they recombine into carbon dioxide, a process that causes the planet's night side to glow. Atomic oxygen has been observed as part of this process, but had never before been seen on the day side. Hubers and his team studied data collected by Stratospheric Observatory for Infrared Astronomy, SOFIA for short, flying high in Earth's own atmosphere in the terahertz wavelength range that straddles microwave and infrared. On these separate occasions, the plane flew, collecting data on 17 locations on Venus, 7 on the day side, 9 on the night side, and 1 at the terminator. At all 17 locations, the team detected atomic oxygen peaking in concentration at an altitude of about 62 miles up, that's 100 kilometers. This corresponds to an altitude that it sits directly between two dominant atmospheric circulation patterns on Venus, the powerful super-rotating flow below 70 kilometers that rotates counter to the spin of the planet, and the subsolar to antisolar flow in the upper atmosphere above 120 kilometers. This means the researchers say that atomic oxygen represents a heretofore untapped resource to probe this atmospheric transitional zone on Venus. Future observations, especially near the antisolar and subsolar points, but also at all solar zenith angles, it will provide a more detailed picture of this peculiar region and support future space missions to Venus, the researchers write. Along with measurements of atomic oxygen in the atmospheres of Earth and Mars, these data may help to improve our understanding of how and why Venus and Earth atmospheres are so different. And this has been published on Nature Communications, and it's on Science Alert by Michelle Starr. Please leave your comments. Thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.